you're going to find in your workspace today, you're going to have a compass, which in a moment we'll talk about the best way to use this. You probably have some type of French curve. Honestly, let's not worry too much about this right now. Everything I want you to draw is freehand, even your curves. Don't get me wrong, you could incorporate this right now into your sketch. I guess you could, but a lot of what I'm going to do is just simply freehand, use this later to go over my curves and clean them up. And obviously you have a ruler. Okay? We've got all the tools we need. So let's focus on this tool for right now, this thing. So if you flip this paper over, yesterday, put in our name, date, period. Okay? We spoke a little bit about how this paper is being broken up. First of all, this drawing is 1-to-1 scale, which means it's actual size, correct? Yep. So what you see is what you get. So what we also have here is a grid. And every one of these squares measures 5 millimeters by 5 millimeters, 5 by 5. We also have, if we take our ruler, a large rectangle that if I measure it, it measures 21 centimeters, which is 210 millimeters. Okay? If I measure the height of it, it measures 50 millimeters. So according to my specs, I cannot make my car body longer than 210, which is this point here, and no taller than 50, which is that point here. So there's my workspace, folks. My car's got to fit inside this space. Dashed line here, we're going to refer to this as our axle line. So somewhere here and somewhere here, we're going to be drilling 2 holes in time. And then we look at this shaded area, this hatched area. Be careful here. The specs tell you that when you're drawing this, the minimum thickness on your drawing is 5. Well, if you were to measure this right now, you would actually find that there's your 5 millimeter thickness. Okay? You can draw right up to the edge of that. You can do that. But there is a little side note here. When the day comes and you're actually cutting out your car and then sanding it, cleaning it up, I will let you, all said and done, you can take this CO2 cartridge housing and go, for example, from 5 millimeters, you can make it as thin as 3. There's no tolerance here, meaning not plus or minus 1, just 3 minimum. So this is the only part of your car where what the specs say is what it can be in terms of minimum thickness. Okay? So this can be no thinner than 3. No thinner. All said and done. The rest of this design does have a tolerance of plus or minus 1. So in reality, I say 180 to 210. If you turn in a car and it's 179 in length, is that okay? Yeah, you're fine. Don't cut it to 179. Cut it to 180. Keep in mind you're probably going to be removing about 1 millimeter of material when you're sanding it. Okay? So that's kind of where the tolerance comes in. All right? Now, one other thing we'll talk about in a minute is this number here, 15. Front view, body thickness between front and back axle. We're not going to spend too much time talking about that yet. We're going to first lay down some lines here for our car body. So here's what I'd recommend you do. I'd recommend right now that you pick up your pencil and start drawing / sketching a car body. Okay? Keep in mind that there was one little step I had you do yesterday, which was take your ruler, put it in the bottom left-hand corner, right here. And as I measure right at the 18 centimeter mark, right here, I put a little dot on my paper. Because I know that when I draw my car body right now, the front of my car can be no shorter than this, and obviously no longer than that. Do we remember that? Okay? So make sure you have that mark in place. And what I'm going to do right now is I'm going to pick up my pencil and I'm going to start drawing. Now, keep in mind, for now, I'm going to use things like the edge of my ruler, which we typically use just for measuring, but for now, we're just kind of sketching. I'm going to use the edge of my ruler to try to draw straight lines. In time, we'll be using things like 30, 60, 90 triangles, but for now, this is fine. So what I'm going to do here is I'm going to actually start my car body right on the edge, right on that end line, which yes, you can do. And I'm going to keep my lines construction. I'm not making anything dark because I can tell you right now, this changes quite a bit, the body of the car, as we keep adding more and more parts. So keep it light, construction only. Now once I get here, I need to think about obviously a nice aerodynamic design, something we've been talking about on the front of your paper. So I'm just going to freehand, and I might end up kind of with some type of bullet shape, so I'm just going to kind of stop right about here for now. Just going to leave it just like this. Okay. And then I'm going to go ahead and pick up my ruler and continue forward. Okay. And then for now, I'm just going to draw something that probably looks kind of like this. Just for now. This could all change. This is just the beginning. Okay, I'm just going to stop right there. So if I look at what I've done so far, height-wise, we said no taller than 50, and if I measure this, that's 40, so that's fine. No taller than the block. Lengthwise, as long as the front of your car falls somewhere between 180 and 210, that's legal. But let's keep in mind that there's one other spec that's going to come in play, and I just want to just talk briefly about it. It's this spec right here. Body thickness between front and back axles, front view, that's the view we're drawing, 15 millimeters minimum. So let me show you a car where I can actually show you the specification. Let's take a look at this blue car here. Okay? So remember, body. We're not talking about airfoils, not talking about side pod. Let's take the body of the car. So here's your rear axle, here's your front axle. So what this spec means is that if you look at this space, this area, the thinnest part of your car body between the front and back axle can be no thinner than 15 millimeters. If I were to take this ruler right here and measure it and see what this kid did, I would say the thinnest part of this car is right here. Right here. Remember, not the side pod, the car body. This measures about 20 millimeters. So this student could have made it thinner had they wanted to. They could have taken off 5 more millimeters and still be within specs. So this is the thinnest part of your car body. Car body. You'll notice with mine, well, first I don't have any wheels, no axles, so it's really hard to say, well, where is the thinnest part of your car body between your front and back axle? Can't really tell you yet, but I did leave this section here kind of thick. For right now, I made mine 20, but I could have dropped down even further and made this 15. But I'm going to leave it at 20 for now because I have an idea of something I'm going to do later. So I'm actually leaving this thicker for now, but it will change in time. Okay? So if I look at my car body, for now, that's legal. That's acceptable. Okay? Any questions? Yes? Say it again? Okay, great question. So here's why I put this here between front and back axle. Because what she's saying is exactly what's happening to all of you. Once I get beyond the front axle, does my car start to get thinner and thinner and thinner and thinner? And basically end at a point? Yes? Yeah, most of you are going to find that. And so once again, the spec is only referring to what's happening between here and here, which obviously then allows you beyond the axle to make this come to a point. So that's, yeah, that's fine. Okay? Yep. Okay? Good question. All right. Moving on. So now we come to the airfoils. Okay, so here's an example of what an airfoil could look like. Okay, that could be a rear airfoil. And for example, that could be a front airfoil. Okay, so now we get to the airfoils. Keep in mind, after airfoils, we're going to have wheels. And then we're going to eventually have, side pods that kind of go in between. Okay, so there's all these different parts. All right? So we talked about convex, we've talked about concave, we've talked about redirecting the air over and around the wheels. So let's take a quick look at our specs. So if I look at my specs for an airfoil, here's what I got. Airfoils. Minimum length, 25. So the minimum length is 25 millimeters. Don't worry about width. That has nothing to do with the front view. But height does. Minimum height is 20. Okay? So minimum 25. Minimum height 20. Okay, so here's what I like to do. I'm going to start with my rear airfoil. I personally like to start in the back, knowing that I need to put a wheel here. Okay? So I'm going to kind of mark some limits. So if my rear airfoil is going to end here, start here and end here, I know that it has to be at least this long. That's 25. So it needs to be at least this length, minimum. It can be longer, we know that, but at least from here to here is 25. I'm going to put my limits for height. Height would be from here to at least here. So if you kind of look at this is my workspace. Now I'm going to do something just so you can visually see what I'm doing. Don't do this. I'm just going to make a box just to use this as kind of an example. So if you kind of imagine there's this rectangle on your paper that measures 25 by 20, your airfoil needs to either fit in it or it can be larger than. But it can't be much, if anything, smaller than this workspace. Okay? So let me show you what an acceptable airfoil could look like. I could do something as simple as this. Let me just erase my box here. I could do something as simple as this. I could say, okay, vertical line here, that's 20 millimeters tall. Okay? And then a curve here. And then a line here. Done. Done. That's an acceptable size for a rear airfoil or front airfoil. And here's how I know that. If I measure the furthest point to the left to the furthest point of the right, that's at least 25. And if I measure the height, that is at least 20. That's acceptable. Okay, let me give you some other ideas. Some kids, rather than make this straight, they might curve this in. Okay, let's just say you do that. Is that still considered legal? The answer is yes. I'm going to use a ruler to kind of show you my limits. So if I take the furthest point to the left and I take the furthest point to the right, when you measure limits, you put your ruler horizontally. So I could basically say that this has a length of at least 25. So that's legal. Okay, but watch this. What if a student were to draw something like this? Knowing that from here to here is 25, is that still legal? So let's measure our limits. That's the furthest point to the left. Is that the furthest point to the right? No. The furthest point to the right still continues to be that point right there, which once again makes this legal. Makes it legal. Okay? But now I'm going to show you something I don't want to see. I hope I don't see this. And it looks great on paper, but this will never survive construction. So, as much as I want you to be creative and make some really neat, cool, innovative looking airfoils, you got to be careful doing something like this. And it looks cool, but the reality is we're making this out of balsa wood. And so when I get an airfoil that kind of looks like that, and as cool and neat as it looks, impossible to replicate that out of a piece of soft grade balsa wood. Because here's what's going to happen. Spec-wise, it works. But in reality, it's not going to look like this on race day. Here's why. You're on the scroll saw, cutting, 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 cutting. I guarantee this is going to snap off. Okay. Big deal, Mr. Bolt. It's still legal. Yeah, for now. You're sanding. Sanding, sanding, sanding. I guarantee that it's going to break off. Okay. Well, I think I still might be illegal. I'm getting close, though. And you're probably going to drop an airfoil, once or twice. Or maybe you keep sanding, and next thing you know, that breaks off. Okay, so that's your airfoil on race day. And the bottom line is, that's not legal anymore. Okay? So when you draw airfoils, keep this in mind. You can always make something that was made too big or too thick, and you always go back and make it thinner. Of course, it's balsa wood, soft grade. It's like sanding air. It's very easy to shape. What you can't do is say, well, I got a small airfoil. Can I make it bigger? Well, here's the short answer. No. Go put that in the trash. Go design a new airfoil. And we need to give you a scrap piece of balsa wood and you need to try it again. Okay? So let's be realistic here, folks. Okay? As much as we're pushing ourselves to make lightweight parts, the reality of it all is we have to have parts that have strength and stability, support. Okay? So going back to my limits, there's my minimum height, here's my minimum length. Okay? I could get away with doing something like this. Maybe I'm going to curve something in. And remember, work in progress. That curve there could eventually change. Maybe I'm going to draw something like this. And I'm just sketching. And I'm going to draw something like this. And this airfoil here has enough material. Yes, it does have points, sharp points, but they're not thin and sharp points. So remember, I could even in time remove a little bit more material after I cut this out and just to reduce a little bit of mass. But as long as I'm keeping that minimum length and minimum height, that's what's important. Okay? You'll probably remember that whenever we cut wood, we never cut on the line. We always cut just outside this line. So we're not going to cut this exactly 25 by 20. We're going to end up cutting it a little bit bigger and sanding down to the outline of your pattern. Okay, so keep in mind, we're always going to cut things slightly larger to begin with. So this is legal. If I were to measure this, overall length is at least 25, and overall height is at least 20. That's legal. Okay? Any questions? Okay. So what do we do next? We draw front airfoil. Alright, so we're going to take that same step. We're going to do the same thing again. And we're going to draw that front airfoil. Okay? Alright, here we go. So, as I work my way to the front of the car, and it doesn't matter which one you start with, some of you may have drawn your front airfoil first, that's fine. Here's what's going to happen next. So I'm going to go ahead and go from here to here. And then, like I said earlier, I like to do this. This is something that just keeps me honest. I know that the minimum length, if I'm going to have my airfoil start from the front of the car and go back, I know that the minimum length can be 25. Now it can be longer. I can make this airfoil 40 millimeters long if I wanted to. I could. It's my car. As long as it meets specs. I'm not saying that's the best thing to do, but once again, you could do that. And now I'm going to draw my front airfoil, and I kind of use a kind of a convex shape here. I might do something possibly maybe a little bit different on the front. And who knows, I might even make this airfoil a little bit taller. I might not. We'll see. And just kind of keep in mind that be careful with these really sharp points. Okay, that we're not setting ourselves up for disaster here when it comes time to manufacture the part. Okay, so I'm always keeping in mind that I need a little bit of thickness here. You can always go back and make a part a little bit smaller as long as it still stays within specs. Okay? You can always make those changes. Okay. You have to be careful with some of these curves. You don't want to make them too sharp. You almost kind of want to find a little bit of a gradual curve, which is why sometimes on my front airfoil I struggle making it the minimum, because then the curve becomes way too sharp. I sometimes find myself that, sometimes I got to just extend the length of my front airfoil just a little bit to get a little bit more of a nice gradual transition. Okay, and remember, this is just sketching. With a tool like a French curve, I can eventually kind of fine-tune the shape of this, but for right now I'm just going to go with this. Okay, now, so let's talk a little bit about wheels and this thing called wheel wells. Okay, so first of all, you don't want to move on to this next step until you have double, triple, quadruple checked that these parts meet minimum specs. Okay? Don't move to this next step until you're sure that what you got is, if not spot on, slightly larger than the specs I'm giving you. Because if not, you're going to end up going back and having to make a lot of changes. Alright? So, this checks out. This checks out. So far the body checks out, and that could be adjusted. Okay, we're now going to direct our attention to a new spec. Okay? So I want you right now just to make sure that things are looking legal. Okay, in the world of airfoils. And here's how this next spec is going to work. Alright, so now that I got my rear and my front airfoil, let's just say this is a wheel that you're going to put on your car. There's one. And there's another. So here are a few things we've got to be very careful with. That distance right there between part and wheel. The obvious is you don't want the wheel to be too close, correct? You don't want the wheel to be too close, because as it spins it could rub against the part. Okay, that's surface friction. Okay? So what I'm going to direct you to is this piece of paper right here. And there's two pieces of information we're going to look at. The wheels have a diameter of 34, roughly. It's a little under 34. It's like 33 and some change, but for right now we'll just say that the wheels are 34 millimeters in diameter. Okay? If you all are looking up on the big screen, you'll see that when we use a compass, I'm telling you which hole to use to accurately draw a fairly close 34 millimeter diameter circle. It's going to be just under, but like I said, the wheel itself is more like 33 and some change. So it's close enough. Okay, so that's a easy thing to do. Draw a circle, been there, done that. But what we also have to be very careful with is this thing called the wheel well. Okay, so let me show you what a wheel well looks like. According to this, wheel well has to have a minimum of 40. So it can be more. And you got to be careful if it ever becomes less than 40. Let's take a look at this car right here. Okay, so here's your wheel well. If you were to take a ruler and measure from the inside of the side pod to the inside of the front airfoil. So watch this, and I'm going to put my ruler kind of on center of that circle. You can see it's kind of a half circle. This student here missed their mark by about 1 millimeter and some change, which could be an issue on race day. So if I start here, that's 0. 10, 20, 30, 35, 36, 37. Their wheel well, this spacing here is about 38. So they're about 2 millimeters shy of what I would consider specs, 40 millimeters. Now, give or take a millimeter, right? Okay. So what does that mean? Well, this is what happens if you make this area too small. If you put a wheel in, I can see where they made their mistake. This side looks good. You see how there's more space here? You see how this becomes a little bit closer to the wheel now? Okay, so big deal. All right, well, here's what's going to happen on race day. As your car is going down the track, of course your wheels are going to spin. But I'll tell you right now, these wheels wobble a little bit. I mean, they wobble. And more than likely, that's going to happen as it's going down the track. If this thing were to wobble too far in one direction, okay, you'll notice there is no contact, right? Okay, I'm actually forcing this wheel as far over as it can go, and it's not making contact. Good. But if I now force it in the opposite direction, what do you see? Oh, contact. So because they fell a little short of my spec, they risk having this wheel, if it does start to wobble a little bit down the track, they risk creating some serious surface friction between here and the airfoil. Now, they kind of did a decent job here, but you can see it got a little bit too close here. So we need to keep that consistent. Okay? Now, you can make a larger gap if you want. Of course you can. But the minimum spec is from the inside of the wheel, excuse me, of the part to the wheel, should be at least 3. So here's how you do it. So if you take a look at your paper, let me start with this airfoil right here. Okay? And I'd really ask that you just hit the pause button for a minute. You got to see it to believe it, folks. So just watch this, and then I'll cut you loose, and you can do this yourself. The first thing we're going to do is we're going to find 20 millimeters. Okay? Watch. Take either airfoil. Take where the airfoil intersects with this dashed line, which I'm going to say, don't do this. I'm just going to put a point here so you know what I'm talking about. This point right here is what I'm referring to. It's where the inside of the airfoil intersects with your axle line. You see that? Okay? You're then going to take your ruler and you're going to measure from that point a minimum distance of 20 millimeters. It could be more, but for right now, just follow along. I'm going to make it 20. So I'm going to put a mark from here to here is 20. So guess what? I just marked the center of my wheel well. Okay, that's the dead center. Okay? Because if this is 20, then I know I'm going to have another 20 millimeter gap here. Okay? That should work out. So here's how we then use the compass. According to my slideshow, when you place this here, you're going to be using the holes on the left, not the first, not the second. The third hole is for drawing wheels. And it's actually very important how you use your pencil. Watch this. I don't just put my pencil inside. I actually keep my pencil closer to the outer edge of that circle. So you have to really kind of push outwards. Here, my pencil's here. It's not on this side of the circle. It's not in the middle. I kind of use the outer edge when I'm making this circle. So as I'm turning, I'm kind of forcing that outward. Okay? So I'm going to make a circle, and it's going to look kind of like this. So make sure that that brass ring is centered, which we can see it's centered. I'm going to take this outer, and I'm going to make a circle. Okay? I'm going to move away. There's my circle. Okay, now I'm not done yet. So in theory, if I measured everything correctly and I drew my circle correctly, I should be able to take my ruler, and there should be a minimum. That's 0, 1, 2, there it is. A minimum of 3 millimeters between the inside of the airfoil and the wheel. Now, don't just think I'm measuring that one area. I could probably measure down here. That looks good. And I can measure here, and guess what? Up here it's more than 3. It's actually 4. That's fine. That's fine. But no less than 3. Or you risk wheels wobbling, moving, and making contact. Now, you could take this one step further if you so choose. Watch this. Some kids like the inside of their airfoil to kind of conform to their wheel. So here's what I sometimes do. I'll actually erase this curve. And if you want to make a wheel well, the same shape roughly as your wheel, I'm going to put that back here. Now I'm going to use that outer hole. And here's what I'm going to do. I'm going to kind of place it right where I need it, which is right about here. And what I can do here is I can actually draw a new curve that kind of conforms to the wheel. Okay? This is all, that's personal preference. You can hand draw it or you can do what I just did. It's really up to you. Like I just mentioned, we got to simply make sure we got to double, triple check that we're getting a minimum of 0, 1, 3 millimeter gap between the wheel and the inside of your part. That's extremely important. Okay? Or we risk, once again, having parts touching wheels. Okay? Any questions? Okay? So what I'm going to do, I'm going to do this one more time. So if you didn't get it the first time, I'll do it a second time. Let me come over here. Okay, so here's the name of the game. First, you draw an airfoil that meets specs. Second, where this dashed line intersects with this inside part of your airfoil, you want to measure out a minimum. You can measure out more. I'm going to do a minimum of 20. So I'm going to go bare minimum. You can go 21. You can go 22. You can go 23. I'm going to do 20. Okay? So once I set my mark, I'm at least 20 millimeters away. Here's where you sometimes have to do some cleanup. Because I'm going to tell you right now, this is probably sloping too far towards the wheel, and I'm going to show you what I mean by that. I'm going to put my compass back on center. Once again, I'm going to be using not the first, not the second, I'm going to use the third, and you try to keep your pencil as far out towards that edge. And I'm going to draw my wheel. And I'm going to tell you right now that this, I may have gotten it, but I may not. I'm going to have to just let my ruler be the judge of that. Okay, so I am spot on 3. That's 3 millimeters. 0, 1, 2, 3. I'm good there. Which means I should be good there, and I'm obviously definitely good here. Right here, this gap right here is about 6. So you got to take multiple measurements. Don't just measure that one area. Okay? So really, people, honestly, that's probably one of the harder steps because wheels play such a big role with the parts. Think about it. Okay? If your wheels and your parts are not properly spaced, then you are creating some serious surface friction. Okay? All right? So as we've said before, we kind of start from the outside. We're working ourselves inward. Okay? What would be the next step? Side pod. Okay? So, at this point, if you can try to catch up, okay, to roughly around, and trust, there's no race here today, folks. We're lucky. We got time to kind of go through this and not feel a bit rushed like my other classes. Not to say I was cracking the whip for 45 minutes, but we were trying to kind of moving at a good pace. We can take our time today with the amount of time that we've been given. All right? But obviously, we want to try to get this drawing knocked out. Okay? All right. Now, so at this point, body, front rear airfoils, wheels, everything seems to be going just well. So now we're going to focus on this space right here. Okay, remember, we're redirecting that air over and around the wheels. What we want to keep it doing is moving. Moving. We want to keep it moving. We don't want that air to get trapped. We want to keep it moving. So that's where that side pod comes into play. And I've seen a lot of variations of side pods. Many of you have seen some on Science of Speed. I mean, some are just rectangular. Some are sloping. Some are curved. Some have some type of maybe parts to the side pod. Okay? But if we look at the spec sheet, once again, here's our limits. Okay? The minimum length is 50, which is, I'm being pretty generous here. You can make a fairly short side pod, okay, with 50 millimeters. But when we look at thickness, we're looking at the front view. There's this number 10. Okay, that's a very important number. Okay? So I want to remind you that I did something here in my car. I actually made my car body 20. And it's because of how I'm going to get ready to draw my side pod. I'm actually going to make my car body a little bit thinner because I'm actually going to take some material off the bottom. Okay? So let me just kind of freehand sketch a few side pod ideas. And many of you have your phones, so you're looking at a lot of variations of side pods. I've seen some that kind of look like this. You know, a student starts like this. You know, maybe they draw a line going straight across. Maybe they go like this, done. Okay? I'm not saying that's the best side pod. I'm just saying that's one way of doing it. I've seen some students where they have kind of a slope in their design. So maybe it kind of slopes downward. Keep in mind it's got to be at least 10 millimeters thick. Minimum is 10. But you know, I've seen some ideas kind of like this. Okay? And obviously I've just seen the good old-fashioned rectangle. Nothing wrong with that. Just a very thin side pod that goes all the way across. And keep in mind your side pod does not have to align with the bottom of your car. I've seen some, and I use this word, that can float. A floating part just means it's not aligned with the bottom of your car body. It looks like this. So we'll say here's the bottom of your car, but your side pod is elevated. It's floating. Now let's just stop and look at this for a minute and ask ourselves, is that legal? Well, minimum has to be 50 for length, and minimum for thickness has to be 10. So I'm going to put my two rulers just to show you my extent. So it goes from here, and it ends roughly here. So if I were to measure the overall length of my part, I'm finding that this part's 75 millimeters long at its extreme points, from here to here, okay, at its limits. So that's well beyond legal. Okay, 50 is the minimum. All right. Another thing I have to measure is what I call thickness, and I don't use the word height. I use the word thickness. This is the highest or thickest part, but it tapers down to the thinnest part here. So if I take my ruler, this should be at least 10, which that is. So that is legal. Okay? I can do that. That's a legal side pod. All right? The thinnest part of my side pod is 10. And if I take the furthest point, it's at least 50. So that's a legal side pod. Okay? I can do that. But now that comes that last thing that we keep talking about now that we have wheels. Do I have minimum 3 millimeters here? I may not. I may not. So as I zoom in, and I'm going to tell myself, you know what? I'm a little too close. Because that's 0, 1. I'm a little bit tight on 3. So all I need to do is I need to erase some of this. Maybe this time around I'll actually put a mark at the 3 millimeter. So I kind of know where my limit is. I need to be at least there. And maybe give myself a little bit more space. There we go. Okay, that's a little bit more like it. All right. So there should be a minimum, there we go, of 3 millimeters there. I'm just over 3. All right. So for my side pod, and trust me, I got some line work to do. This drawing is far from object lines. It's all construction. But if I were to ask you this question, is this considered a completed drawing with the required parts? The answer would be yes. And here's why. The required parts are a car body, check. Rear and front airfoil, check. Wheels, check. And a side pod, check. So that's considered complete with all the required parts. But there is an optional part, right? What is that optional part I could add? I could add a spoiler. And you have a choice. Okay? So at this point, I could basically say that this car, for the most part, is done in the front view. Okay? It's done. I can move on to the next step. Now, I'm going to draw one because I'm sure there might be 1, 2, 3, 10, 15, 20 of you that are considering a spoiler. So I'm going to draw one because I can. Okay? For this last step. And don't get me wrong, I know that's going to be a hidden line. There's a lot of line work that needs to be done here. But for right now, I'm just laying down construction lines. Okay? Any questions so far? Okay. All right, so let's talk about a spoiler. So as always, let's look at our specs. Keyword is optional. You don't have to put one on, but here's the good news. You could draw one today, realize later you don't want to do that. It's fine. You might end up not drawing one today, and later realize, I want to include a spoiler. You can do that. Okay? So you can change your mind on this one. But I'm going to draw one because I want to show you what it looks like. Minimum length is 20, so this is a pretty short piece. Minimum thickness is 3. But let's just pause for a moment. If there's a tolerance of plus or minus 1, all said and done, how thin could that be? 2. But I'm not going to draw it 2. I'm going to draw it 3. And when I manufacture this part, I could end up with something even thinner and still meet specs, okay? All right? Okay? Now, some kids will make this out of balsa wood. Some kids will make this 3D print this. And this is something I would consider 3D printing because it's very small and it's going to be lightweight. But I'll tell you right now, by volume, balsa is lighter than 3D printed material. Okay? So it's best to try to replicate or make this out of balsa, but you could 3D print it. It's very small, so it's a very insignificant amount of weight you're adding to your car. All right? So here's how we could approach this. We could do a few things. We could, number one, put it right on top of the car as long as when we add the spoiler, the car does not exceed a height of 50 millimeters. Okay? Why? Because even with the spoiler, the body height cannot be above 50, even with a spoiler. So what some kids do is, if they have the space, they'll put it here. And some kids will just put it somewhere on the side of the CO2 cartridge housing. Okay? Personal preference. So I'm going to put it on the side of the CO2 cartridge housing, because I can. So I'm going to draw some limits here. I know that the minimum length can be 20. And I'm just going to keep this completely horizontal. So I'm just going to draw a line that's 20 millimeters long. So we know that's the minimum length. And I know the minimum height has to be 3. So now I'm going to put a mark here at 3. Okay. I'm going to go ahead and once again draw a new line here, parallel. Now because this is a part, I want to give it some good aerodynamic properties. A lot of times I'll do this. I'll kind of round off the back. Some kids might even make the back pointed. But I will definitely do something to the front because this is where we make contact. And a lot of times I and students will kind of put what I call kind of a taper. Kind of like the fin of a rocket. Imagine that. There's that taper again. Okay? You get the idea. This, at the end of the day, folks, this is a really small part of the car. It's very small, very lightweight. Which, as we said before, this is a little bit more of a aesthetic component than really a performance component. Okay? All right. Okay? I'll leave it at that. All right? Spoilers are pretty easy. Like I said, They could go here. They could go here. Some kids will even, rather than putting horizontal, put them slightly at an angle, which in theory is what a rear wing does, creates a downward force. Okay? But right now, I would have to say that this is now, once again, a completed drawing. I got all the pieces and parts. Okay?